watershed layers, if you learn anything about Carlson hydrology, watershed layers is awesome for you to use. Nobody says you got to, but it's awesome. And with a little setup work in the front end, when you lay these things out, the easier it will be later on, and when you do decide to start doing storm. So let me go ahead now. That's the only thing we really need to worry about in watershed. So, you usually end up with two. So let me show you before I go. I'm going to load. Now I've got a pre-construction here just so you can see what it looks like. There's nothing here. So if I, and what I'm doing is the North Carolina Department of Environmental and Natural Resources. I come in here and I can set it in here, unimproved areas, whatever. We could leave it just like that. And everything out here gets a 0.2 runoff coefficient. In pre and post, we come down, we load our post. There's our different layers and things like that. Let me set this guy because I see him not behaving. Let's go. Let's do this. Let's come up here and get something single family. We'll use single family for that just because I like the bigger number a little bit. So I'm going to hit OK. Now what we're going to do is I'm going to unisolate all my layers here so you guys can see. Here's my CAD file. Now, when I lay out my storm, I have to come in here and I've got polylines in here that show, like my storm drainage center line. Okay. I use these because in a preliminary plan, I have to lay this storm out, but I am not designing it at that point. So what I'm going to do is I use these lines as snap points. Okay. Now for me, in Mark's world here, you can see that when I pick these two polylines, my PC is about right here. So my catch basin is 2.5 feet back from my PC. And that's why I put these in here so that I can have a point of reference and can snap. That's the only reason. So it's just like me, a little guide of what I think I'm going to have to do. So next thing I'm going to do is I'm going to come into network and I'm going to go to sewer network settings. So when I come into sewer network settings, we have to make decisions right now about what are we going to do? Is this going to be storm that has hydraulics, or is it going to be sanitary utility, which is gravity and maybe some pressure pipe or something like that? But what we're going to do is we're going to come down here and I'm going to do a brand new SEW file from a storm drainage. So I'm going to hit select. Let's type in new. I will go SD, and I'm going to put today's date, 2/16/22. Maybe we'll put space and open. So as you see, I'm creating. This is going to be very brand new. Now, when I'm not sure if you guys have had the surface model teaching yet, but what I do with my surface models is I typically have three. Okay, there's existing ground, there's my proposed grade, and then there is one that I call merge. Okay, merge is where I take the design and merge it with the existing, and I save as merge. The reason this is going to be, the reason I merge the existing and the proposed is because this is going to be my post-construction surface model. Okay. And so, and then my existing grade is my pre-developed. So that's how this thing is kind of thinking just for you guys. And as you can see, I'm just going to go ahead and leave it with my merge 10. Okay. Now, this is my opinion personally, and I like to link my sewer network to reference surfaces and center lines, I think is what that says. I got cut off or something. And I typically like to keep my options at prompt because if you turn it off, it's not going to do anything. If you set it to prompt, you're going to have to say yes or no. And if you set it to auto, it's going to happen and you never know it. I don't like that when it comes to my storm drainage design. So I go prompt. I don't want a computer program. I like the way it thinks. I love what it does for me, but I need control. And so that's where prompt comes in. Now, you can also specify specific locations to use your inlet library. I leave mine as current, but you could go and select your inlets from our library. You have the sewer structure library, which is what's below ground. Okay, 5x5 catch basin, with an open throat and grate. That the inlet is the open throat grate. The structure is what's below ground, the 5x5. Your pipe size library, you can set that to current or you can set it to specific. If you guys wanted to go and set something like this, you could go in here and you see once you get into Seco and Carlson project settings, I have placed in all of the C76, RCP 3, 4, and 5 with all the different wall thicknesses in here. Now, the one I typically use is always this one. That's the one I set up for me when I was doing it myself in the real world. So that one. Now, these all come out of the ASTM C76 materials, standards, and specifications for reinforced concrete pipe. These are the bare bones minimum wall thickness. Most pipe manufacturers, they're a little bigger. Okay, so this is just something to give us a guide because the cool thing about Carlson software is we're going to be looking at outside diameter versus outside diameter, not the inside diameters. We're not going to look at that. So what we do is I like to add this. I'm not going to do it now because actually this is my current one. I use it every time. So I'm just going to go ahead and I'll say open, but so if I wanted to edit it, I can come into my pipe size library. Maybe we'll leave this. And since we're doing storm, my smallest storm drainage pipe is a 15-inch. So I'm not even going to use these three. They're there because I use them for my HDPE and uh, PVC gravity pipes and stuff. But for me, my bare bones minimum is 15-inch. Now, the last time I was in design, I could not get 21-inch pipes. I could not get 27-inch pipes, and I could not get 33s. So let's just take them out of the design. If you can get them, use them. But the key thing here is that we're looking at is like with a 24-inch pipe, we have a 3-inch wall thickness. Okay, when you're trying to maintain 18 inches of vertical separation, 3 inches is quite a bit. So keep that in mind. These are built into the software for you. You just have to go get them. Okay, now what I'm going to do, I'm just going to set mine back to current just to be done with it. Now, as we go, we have to go through each of these tabs. And so what I'm going to do is I'll come over to my design tab. Now, once I've placed all of my structures in, we're going to come back to automation and let the program design it for us. See what it gives us. Auto connect structures, just prompt me. Your HGL computation, federal highway. There's a couple in here if you're VDOT or Ohio. If you have others that you may need to use, let me know. And I can try and get some of that stuff in here for you guys. The friction slope, we got arithmetic, abeyance, and geometric. The HGL offset from the rim. This right here, I have it set to 1 foot. So I will allow water to back up into my catch basin, the structure underground, until it's about a foot from the from the rim. Okay, I don't want it surcharging, but I'll let it back up. Okay, so I set that here. If you want to, so be it. It's y'all's call. Your minimum time of concentration. Mine in the state of North Carolina is 5 minutes. I've seen other folks who can use 10 minutes, but 5 minutes is what I use, period. So now, also I can specify my maximum gutter spread here, which typically is half the travel lane or 8 feet. You know, those types of things. You'll always get, it'll be in your manual what they want you to do. And then, what is the initial structure name? I'm going to use CI curb inlet 1. Okay. I'm also going to work from the upstream end to the downstream end. You can flip flop anytime you want to here. Just remember which one you're doing. Now, if you were designing to a tailwater condition, then maybe I would design downstream to upstream. Okay. And so starting at my tailwater condition, work my way back up the system, or I could just go upstream to downstream. Want to keep these pipes shallow. This is the way I typically work. So I'm just going to let it ride. Now, if you start connecting tributary pipes, you can specify if you were to bring in a tributary pipe and it was too low, it would lower the main structures and everything by the current slope that's already there, or by all kinds of options. You can lower and raise and all the current minimum slope, things like that. So if you start adding in, like perhaps here, where we add a tributary coming into our main line, maybe we have to follow some of these properties to make that work correctly. Not sure yet. Now, down here, there's a few check boxes, and I will kind of uh, explain a little bit. You get your rim elevation at the inlet location, which could be in the gutter pan or the back curb or whatever. Always capture all inlet flow. Okay, bypass disabled is what it says. Well, what this is when I design my pipes, I always, it's like a little safety factor for me. I always capture all flow to that inlet. Whatever's in that drainage area, I'm saying it goes to that inlet, every bit of it. And there's no bypass. So when I size pipes, it's a little bit conservative, if that makes sense. Um, so I do that. Now, once you have everything and you've got your uh, pipe sized, you come back in here and turn this off, and then you can analyze the system and you're going to start to see bypass calcs. All righty, hold on. I got me a question. No, it will be fine, Scott, for you to go ahead and use metric if you like. It's just when you do, just make sure you have to set that in a lot of your older settings, like in the settings Carlson configure. Just go through some of that, but it's fine if you want to. So I just answered another question for a guy. Now, let me turn this back on because we're going to size pipes. Now we're going to go to the drainage tab. We got to select the method again. We're going rational. What am I after? Do I want peak discharge or do I want to get hydrographs out of these pipes? I can get either one. And, depending on which, I'm just after that Q. Adjust the rational method for higher frequency storms. Some municipalities have this. This is like a multiplier, like 1.1, 1.2 multiplier for those higher frequency storms. And then, of course, we have use a different rain event for inlet gutter spread and ponding depth. Now, I have to do that because where I'm located, they want me to use 4 inches per hour. Okay. So what I have done is if you look down here, you can see here's my rational rainfall library for my pipe sizing, and I'm doing it to the 10-year storm. Okay. And you can get these from your rainfall libraries. For example, if I look at this one, the one I selected, it's a rainfall intensity, and edit it, and you can see here's all the data that corresponds. 5 minute minimum time of concentration, the 10-year storm is 7.296 or 269 for me. So that's based off of NOAA. And if I have time at the end, I'll show you guys how to get that crap. It's easy. So I'm just going to go ahead and say okay here. And so my rainfall for my pipe sizing using NOAA Atlas 14. Down here, the inlet for gutter spread, I've got one in here. You see, here it is. If I edit it, this is the same thing I was showing you a minute ago. I give it a name and what's the intensity. And that right there, this is a fixed. So, it's going to use 4 inches per hour no matter what. For my gutter spread, you could set that as your 10-year storm if you wanted to. It's kind of up to you, but you can see Wake County gutter spread. Now, had we switched to the SCS method, this area up here would have been gray out, and then we would have had this open up for us, and you can go in and start typing in, storm type 2 24 hours and things like that in here for yourself. Now, let's go ahead and press on. We'll go to the pipe tab. So this is what the program is going to try to design to. And if it doesn't, it's going to let you know. Okay, you'll have to fix it, but it'll let you know what's happening. So first thing, the minimum cover. What's the minimum cover on most of our pipes? 3 feet. We want to keep them. We want to keep these storms shallow, so I'm gonna go with 3 feet. And what I want it to do is, if I go over 10 feet deep, I want to be told. Okay, most of the time I'm gonna be around here. My velocity. Different jurisdictions have different requirements. Like where I'm at, some they want 2.5 feet per second in the pipes to keep them clean, keep them all cleaned out. And then I want to be told if I go over 10 feet per second. Okay, just something I want to know about. Now, down here on our slopes, my minimum slope is well, it could be 0.45, but trying to design to that is going to get you in trouble. So typically I go with about 5.5. The reason being, now if I have a cover problem, people, all bets are off and I'm going with the bare bones minimum. But under normal conditions, this is what I want. Now, if I come down to the main design criteria here and I flip that over to slope, then here's going to be the minimum slope and here is the average I want the program to do. So if it can't, by cause of cover or whatever, stay at 0.55%, well, let's go ahead and just make it 0.75%. But if we start having problems, take her down to that. Okay, and that's just because I toggle here. So you can see that gets grayed out. Now the program's going to use 0.55. Okay, whereas if some pipes could be 0.75, but where I got a cover problem, I need to be 0.55 or 4 or 5, whatever. So that's just things that you could do in here, but that's what the toggles are happening down here too. So the maximum length, I'm 400 feet between structures. Okay, that's what is required of me, and I will try to put like 2.5 feet pre-drop inside of a structure or a manhole. Sometimes that's frowned upon, but 2.4 for me is the maximum amount of free drop I can have in a structure. Okay, sanitary sewer and storm. So I kind of look at it that way. Now, the drop across my junction. So inside the catch basin, we're looking for 2/10 drop. Invert in will be 100, invert out 99.8, 2/10. Okay. Some people do 1/10. Okay, it's up to you. Or you could say this is fixed for all junctions or minimum for all junctions. So I'm just going to leave it as probably fi fixed for all junctions right now and let it be. And we'll see what we get. Now, uh, pipe at junction match, storm drainage, match your crowns. It just makes the HGL and everything work so much better. Match your crowns. The main design criteria. Now, sanitary sewer, go with inverts. The check minimum cover. I've noticed in this program, just my own notice, is that if I check the depth or the minimum cover at structures, I usually am okay along the pipe runs. Okay. So I've got another question here just popped up. Way Yeah, he's asking, is there a way to change the display size of a manhole symbol in plan view? Yes, you can, Ron, and I'll show you in one moment what I'm talking about. So, also, now this was added in last year, I believe, where we could come in here and Ron, I'll point that out to you when I get to it. Like zone one, let's just say 8 feet. What's the easement width? Let's go 20. Anything maybe 10. Let's go 30 or maybe 25. And so you can have, based on depth, the easement widths that you need, and the program will draw those easements for you. I really don't like doing it until I'm kind of done, if that makes sense, because I don't want it to be redrawing all this stuff while I'm designing over and over, and changing inverts and all this other stuff. So what I like to do is I'll hold off on this, uh, but it's there if you want to use it. Okay. Under our lateral tab, this is more associated for me along the lines of sanitary sewer cleanouts. Okay. Now, if I have uh, downspouts or anything like that for roofs, leaders, and things like that, I'm going to use those in my storm network. I'm not going to use laterals. I'm going to make a little 6-inch or a 4-inch type of pipe and let the roof drainage come down that into my system. So this is more along the lines of sanitary. Now, air checks. So when we design storm drainage in here, had we created another SEW file, for example, maybe I'd already designed my sanitary sewer. I could put that in here and collision check against it and say, I need 18 inches. Okay, what that's going to do is it's going to let me know and show me these conflicts. Let's just say if I went and selected a sanitary sewer file. Okay, so now you can see I'm going to check against this one. Now you can check against as many of these things as you want to, but as you design, you get one. Okay, also we got the ability to show check circular manhole size. So what this does is it checks to make sure you don't double hole a manhole, where you've got like almost like a figure 8 shape, two holes coming into the same invert, and you got to make, you got to make them fit. That's what this is doing. And you can see the minimum distance between the holes. I keep about a foot. Okay. Now, if you want to use it, use it. If you don't, don't. So it's kind of like if you got it, use it. It's okay. If you don't want to, do not worry about it. But I'm going to show pipe crossings. So now we'll go down. Now check. This is the collision check with another sewer network. So if we select, like I did sanitary, we can go. Now, Gonna go down to display. Very simple, straightforward couple check boxes. So display slope in percent. That's what I like. Elevation distant decimals. I use 2. You've got other options in here. And I like the round elevations to the decimal. Okay. So, maybe, yeah, I'd probably leave it just at 2. That's typically what I do. Show coordinates and show drainage area perimeter at structure locations. These are 2 options if you want to. I think I will show this guy just so you guys can see. Okay. And I always leave that tooltips on. So, boom, we've gone through our settings. Okay. Now what we can do is come in and start adding in storm drainage. So I'm going to go to network. I'm going to come down here to create a sewer structure. And now what it does is it comes down here and says pick a starting point or point number or station and offset. Well, this is why I have my snap polys. Okay, that's what that's all about, is just me snapping. And so what I'm going to do is I'm going to accept the default, hit pick, and I'm going to come over here and I'm just going to snap to the endpoint of that line. And so now here we go. We're going to start doing our storm drainage here. And what we need to do is tell it everything we possibly can about catch basin 1. Okay, so I don't really, it's catch basin 1, system A is fine. What's the inlet? Uh, NCDOT, great. Let me see what I got in here. Yeah, let's just go with the NCDOT, great. This structure underground, I'll make it a 5x5 catch basin. If I had a tailwater condition, I could put it here and design downstream to upstream. Okay. I do want to select a reference center line. So I'm just going to screen pick and grab a hold of my polyline. And in RoadNet, we had called this Road 1. So you can see that it has assigned Road 1 to this. And the reason I do this is for the rotation of my symbol. So, of course, your northing and easting is where the triangle is, where we picked. Okay. And we come down through here, the symbol name. Well, you can see that symbol right there. That's my symbol for a catch basin. Okay. But it's kind of big because it's being drawn at the scalar. Ron, this is where, and let me see if I can explain this to you. When I draw this right here is a DWG all its own. I put this one catch basin in there with 0,0, comma 0 at the insertion point, the back of curb for me, because that is the rim elevation I'm looking for and what will be staked in the field where I'm at. Now, check this out. So hopefully this explains it. Now, in my CAD file, Ron, this is drawn 1-to-1. So if it's 5x5, it should be 5x5 on the dimensions. But right now, it's being scaled. Okay. What I do is I will come in, draw them 1-to-1, and turn them to a unit symbol. Boom, instantly it decreased the size. And so now what I could do is if I come in here and I say, I want the rotation of my symbol to be parallel to center line up. Well, that's not far enough. So it looks like it's parallel to center line down, which would flip it 180. And so now you can see, and the 1-to-1, this is my grate. This is the hood, and the opening is in here and in these holes. So that is how I control the size of those symbols. My symbols are 1-to-1. If it's a 4-foot diameter manhole, draw it 1-to-1 in its own drawing file. Or take one. This one right here, I downloaded from NCDOT and made it the size I wanted it. And then just save as catch basin. So hopefully that helps. It's hard to answer question. Yeah, do you have VDOT curb inlet blocks? No, I don't, Ron, but I may know someone who does. So I'll check with them and see what what they think. And if I can and they don't care, I could send them to you, but I'm not sure yet. So we're just going to keep on going. So now, parallel to symbol on down, unit symbol, the rim elevation, and like let's say if you were on an outfall, you could say, well, this is the actual ground surface here. This, you could raise it 1.5 feet just so you could find it in an outfall, not flush to the ground where it'll get covered up. Also, right here, we can tell at the depth right off the get-go, excuse me, for this first box. So what I'm going to do is I am going to call it, my first pipe is a 15-inch. So let's go 1.25. That's the depth, 3 foot of cover with a 15-inch pipe. That's where that first number come from. Then you see, if I type that in, I could come down here and see what the invert out, and I do not leave 0.22 for anybody. I would come back in here and I would probably just go and be done with it. So now I'm 5.74 feet deep on that first box. Okay. Now, the reason we want to tell it all this stuff is because the next one we add, it just adopts these same settings. So it becomes easier. I don't have to worry about switching this stuff up here anymore. I just have to, start putting in my boxes. So